In 1972, Ford Motor Company sent every dealership in America a catalog of tools marked required, not recommended, required. If a dealer didn't own them, Ford refused to reimburse the warranty claim. Independent shops couldn't buy them. Every tool in the catalog was designed for one job on one vehicle that couldn't be done any other way, and Ford said so in their own words. There was no approved alternate method. That's why the dealer charged more. These are the tools your grandfather was paying for. Subscribe before we start. Ford called the program Rotunda. Every tool had a coded part number stamped into the metal. The prefix T meant tool. The next two digits told you the year it was introduced. A letter at the end told you which Ford vehicle line it fit. B for Thunderbird, K for Falcon, N for Lincoln, P for passenger car. You ordered them on a Ford form, shipped from the National Parts Depot in Livonia, Michigan. The independent shop down the road couldn't place the order. These tools were sold to Ford dealers only. Number 15, cylinder ridge reamer. Every engine wears a ridge at the top of each cylinder bore where the piston rings stop traveling. Pull a piston without cutting that ridge first, and the rings catch on it, cracking the ring lands and destroying the piston. Ford required every dealer to own a reamer with a tungsten carbide cutter that could remove the ridge cleanly before piston removal. Part number T64L6011EA, one tool, one cut, one job. Without it, an engine teardown became an engine rebuild. Number 14, power steering pump pulley replacer. Ford's power steering pump pulley was a press fit on the pump shaft. The catalog warned in plain language that pulling or pushing directly on the shaft would damage internal pump components. This tool threaded onto the shaft and used a roller thrust bearing to press the pulley on or off without any force reaching the pump internals. Ford made the warning explicit. Use this tool or replace the pump. Number 13, camshaft bearing installation kit. Part number T65L6250A. Ford's catalog said this tool superseded every camshaft bearing tool that had ever existed for their engines. All of them. Replaced by one kit with a three-piece shaft design that fit every Ford engine block, car, and truck, packed in its own metal storage box. Every Ford engine had camshaft bearings pressed into the block, and installing them crooked or to the wrong depth meant oil starvation. This was the one tool that Ford said covered everything. Number 12, piston pin remover and replacer. Ford engines used press-fit piston pins. The pin was pressed into the connecting rod with an interference fit tight enough that it couldn't be driven out with a hammer without cracking the rod or destroying the piston. Ford's tool used screw pressure to push the pin out and press the new one in without heat, without impact, and without damage. The catalog listed it as required. Ford's word, not mine. Number 11, steering sector shaft bushing tools. This is where Ford's system got expensive. Ford didn't make one steering gear. They made different gears for different vehicle lines, and each gear had different sector shaft bushings. The Falcon had needle bearings starting in 1964. The Thunderbird and Lincoln had integral power steering with its own bushing dimensions. The Fairlane was different from both. Each one required its own dedicated removal and replacement tool. A Ford dealer in 1972 needed 4 or 5 separate sector shaft tools just to cover the vehicles pulling into his service bays. Each one was a different part number with a different price. 4 or 5 tools, one purpose, because Ford couldn't build a steering gear the same way twice. An independent shop needed 0 of them because he couldn't buy any of them. Number 10, front coil spring remover and replacer. A front coil spring under compression stores enough energy to kill a man. Ford's suspension design placed the spring between the upper and lower control arms, where it couldn't be safely removed without a tool that compressed it in a controlled manner. Part number T63P5310A. The catalog listed it as essential for every Falcon, Comet, Mustang, Fairlane, and Thunderbird. Essential. Not one of those springs was coming out safely without this tool. Number 9, valve spring compressor for FE engines. Ford's FE big block powered everything from the Galaxy to the F-Series truck. The valve train sat deep in the cylinder head under a heavy spring, and the only way to replace a valve stem seal or check a weak spring without pulling the entire head was this tool. It hooked under the rocker arm, and its long handle levered the spring down far enough to remove the retainer locks. One tool, specific to one engine family, required because Ford designed the FE with clearances that made every other compressor useless. And this is the one most people wouldn't recognize as a tool at all. Number 8, hydraulic tappet leak down tester. This is not a wrench. It is a precision, calibrated weight load device that measures how fast a hydraulic valve lifter leaks oil under a controlled load. Ford's catalog described it as friction-free and calibrated. You filled a container with white kerosene, submerged the lifter, placed the tester on top, and timed how long it took the plunger to travel a set distance under the weight. Too fast, and the lifter was worn. Too slow, and it was stuck. The test determined whether a lifter met factory specifications or needed to be replaced. Every Ford engine with hydraulic lifters required this test during a valve job. A mechanic could hold a lifter up to his ear, press the plunger with his thumb, and guess. Ford did not accept guesses. They required a measured leak down rate against a printed specification, performed with a calibrated instrument, and documented. No other tool could perform the test. Number 7, upper main bearing insert remover. The crankshaft in a Ford engine rides on split bearing shells. The upper half of each shell sits in the engine block, trapped under the crankshaft. Replacing it normally means pulling the crankshaft, which means pulling the engine. Hours of labor and hundreds of dollars. Ford's tool was a thin pin with a swiveling head that inserted into the crankshaft oil hole. When you rotated the crankshaft, the head pushed against the bearing shell and walked it out of the bore. Turn it the other way and it walked the new bearing in. An entire engine pull replaced by a quarter turn of the crankshaft. Number 6, valve guide reamer kit. Most engines use replaceable valve guide inserts that press into the cylinder head. Ford didn't. Ford cast the valve guides directly into the head. If a guide wore out, you couldn't knock it out and press in a new one. The only repair was to ream the existing guide to an oversized dimension and install a matching oversized stem valve. Ford's kit contained 3 precision hand reamers, each ground to a specific oversize, 3 thousandths, 15 thousandths, and 30 thousandths. Each reamer piloted in the hole, cut by the one before it. If you didn't own these reamers, the only option was a new cylinder head. Number 5, locking differential torque check. Ford's Equilock limited slip rear axle used a clutch pack that had to be assembled to a specific torque. Too loose and the differential wouldn't lock. Too tight and it would bind. Ford's tool measured clutch pack resistance after assembly both on the bench and in the vehicle. It threaded onto the pinion shaft and accepted a standard torque wrench. The reading had to fall within a published range. If it didn't, the differential came back apart. Number 4, crankshaft damper replacer. The harmonic balancer on every Ford V8 is a press fit on the crankshaft snout. Driving it on with a hammer risks cracking the damper or damaging the crankshaft keyway. Ford's tool threaded into the end of the crankshaft and used a forcing screw to pull the damper onto the shaft with even, controlled pressure. The catalog didn't call it recommended. It said there was no approved alternate method. Ford designed the fit so tight that no other installation technique was acceptable. Number 3, spindle ball joint remover press. Ford's front suspension used tapered ball joint studs pressed into the steering knuckle. The taper lock that held them in place was strong enough that a standard puller could not break it without bending something. Ford's tool was a forged steel press with reinforced legs and side retaining bolts, built to withstand what the catalog calls severe assist blows without damage. The catalog's own description of attempting removal without it was 6 words. Very destructive, if not completely impossible. Number 2, differential housing spreader. Ford's rear axle housing was designed with an interference fit on the differential bearings. The bearings are pressed in so tightly that you cannot remove the ring gear carrier without physically expanding the housing. Ford's tool clamped onto the housing, and a hex screw expanded the entire casting by 10 to 15 thousandths of an inch, just enough to lift the carrier out. When the screw was released, the housing returned to its original dimension. The catalog described it as stretch, and it was the only way to get inside a Ford rear end without destroying it. Number 1, pinion depth gauge. A friction clutch micrometer permanently mounted in a cross shaft with stepped-in rings and hold-down clamps packed in its own wooden storage box. This tool set the pinion gear depth in Ford's legendary 9-inch rear axle, the axle that went into everything from Mustangs to F-Series trucks to drag cars running 7-second quarter miles. The pinion had to sit at exactly the right depth relative to the ring gear centerline, a few thousandths of an inch off, and the gears whined, wore, and eventually failed. No independent shop had this gauge. No aftermarket company made an equivalent that Ford would accept. And the gauge itself was one of the most expensive tools in the entire Rotunda catalog. A dealer could spend more on this one instrument than most independent shops spent on their entire specialty tool inventory in a year. The reading from this tool determined whether a 9-inch rear end was built right or built wrong, a few thousandths off in either direction, and the gears would announce the mistake every time the car moved. Ford required every dealer in America to own one, and every dealer in America paid whatever Ford charged. Every independent mechanic in 1972 had the same wrenches, the same socket sets, the same screwdrivers as the man behind the Ford dealership counter. The difference was 15 tools he couldn't buy and a catalog he never saw. Ford designed their vehicles so that the critical jobs required proprietary tools, then sold those tools exclusively to their own dealers, then tied warranty reimbursement to their use. The dealer didn't charge more because he was better. He charged more because Ford made sure he was the only one who could do the job right. Every one of those tools was a toll booth between the customer and the repair. Ford designed the car, designed the tool, sold the tool exclusively to the dealer, and tied warranty payment to its use. The tools weren't a service, they were a business model. If you enjoyed this video, subscribe and watch the next video above.